Hi everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look at half equations and ionic equations. Hopefully by the end of this lesson you're going to be able to write half equations and ionic equations for a range of reactions. To start off though, we've got 3 questions based around the work we've done in recent lessons. So have a go at answering those 3 questions in your books. Let's mark those answers then. So for question 1, we need to put a 3 in front of the NaOH and a 3 in front of the H2O to balance it. Question 2, our word equation should be sodium hydroxide plus hydrochloric acid makes sodium chloride plus water. And then for question 3, what we should have is 7 grams, and the reason is that mass is conserved in a reaction. And if we look at the reactants, we had 10 grams of one and 5 grams of the other, so a total mass of 15 grams of our reactants, and we know that one of the products was 8 grams. So 15 minus 8 gives us 7 grams. Before we jump into the half equations, let's just have another go at word and balanced symbol equations. So have a go at writing the word and balanced symbol equation, including the state symbols, for the reaction I've given you at the top. Hopefully your word equation is sodium plus chlorine makes sodium chloride. And remember, if you've not got the endings on chlorine and chloride correct, you don't get the mark. And then for our balance symbol equation, it should be 2Na plus Cl2 makes 2NaCl. And our state symbols are that sodium and sodium chloride are both solids, so an S in brackets, and chlorine is a gas, so a G in brackets. So total of 3 marks for that one. Give yourself a score out of 3. The first thing we're going to do is have a look at half equations. Now, when we talk about a half equation, what we're referring to is a model for a change that happens to one reactant in a chemical reaction. So rather than looking at the entire chemical reaction, we're going to focus on just a single reactant and then see what happens to that one. So write that definition down in your books first of all. If we start by thinking about sodium chloride, what I'd like you to do is write down what ions sodium chloride contains and then explain how each of those ions forms. What we hopefully got is sodium ions, Na+, and chloride ions, Cl-. Now, in terms of how our sodium ions form, we start off with a sodium atom, and that atom is going to lose an electron to become the sodium ion. So I've given you an equation there. We start off with sodium as an atom, just Na, and it's going to form the sodium ion, Na+, and an electron, which has the symbol E-. If we then look at our chloride ions, we start off with a chlorine atom, and the chlorine atom is going to gain an electron to become the chloride ion. Now, hopefully for the equation we remember that the halogens are diatomic, so they go around as a pair, so we always have to have the little 2 in the bottom right. So we start off with Cl2, and each of those chlorine atoms needs to gain a single electron. So onto that we add 2 electrons, 1 for each chlorine atom, and we will make 2 chloride ions. So Make sure you've got those points written down if you didn't already get them, and then see if you can answer why we have 2 electrons in the equation at the bottom. Hopefully we said that we've got 2 electrons because each chlorine atom needs an electron, and there are 2 of them. So what we actually did on that previous slide was we wrote half equations, because we focused on what was happening with the sodium and we wrote that bit out, and then we focused on what was happening with the chlorine and we wrote that bit out. So that's what we've got with our half equations. We look at one of the reactants and we just say what happens to it. So what I've got for you here then are 3 different reactions, and I'd like you to have a go at writing half equations for those reactions. And don't forget to label which is an oxidation reaction and which is a reduction reaction. what we've got on the screen now then are the answers to that. Now, if we look at question 1, we started off with calcium and oxygen reacting to make calcium oxide. So the first half equation is looking at calcium. So we've got calcium atoms, which then become calcium ions, and calcium is in group 2, so it's going to be Ca2+, and if we look, we've got 2 calcium atoms in the actual balanced equation there. So that means we've got to have 2 calcium atoms in our half equation, which means we've got 2 calcium ions, and each calcium ion has a 2+ charge, so we need 4 electrons overall. So 2Ca makes 2Ca2+ plus 4E-. And because the calcium is losing electrons, it's an oxidation, because remember, oxidation is the loss of electrons, reduction is the gain of electrons. The other reactant we've got is oxygen there, so we start off with O2, and then we're going to form oxide ions. Now oxygen is in group 6, so that means it will form 2- ions. So what we've got is our 2 oxygen atoms will then need 4 electrons to become 2 O2- ions. And that, because we are looking at a gain of electrons, is a reduction reaction. So I'm not going to read the other ones out, but do have a look, mark the ones you've got correct, and if you want to write the corrections in, obviously do so you can see how we get those answers. And then you can give yourself 1 mark for each half equation you got. So it's a total of 6. The other type of equation we could be asked to talk about are ionic equations. Now, a complete ionic equation shows the ions present in a reaction mixture, and it will usually also include the formulae of any molecular substances or substances we find in the solid state. So jot down those 2 sentences first of all about the ionic equations before we actually have a look and see how we write these. So at the top, we've got our balance symbol equation for the reaction. So in this case, hydrochloric acid reacting with sodium hydroxide to make sodium chloride and water. So if we write the complete ionic equation, we need to write down every ion involved. So what we start off with, if we look at HCl, then that's made up of hydrogen ions, H+, and chloride ions, Cl-. So there's our first 2. Then NaOH is made of Na+ ions and OH- ions, hydroxide ions. That's going to make Na+ ions and Cl- ions in our sodium chloride and water. Now remember, water isn't an ionic molecule, so we just leave that as H2O. So that's the complete ionic equation. But if we look at it, then what we can see is that on the left hand side and on the right hand side there are some ions that remain the same. So if we look, Cl- on the left, Cl- on the right, Na plus on the left, Na plus on the right. So they're the same on both sides. Any of those ions that are the same on the left as on the right, then we refer to these as spectator ions, because they're not taking part in the reaction, they're just sitting back and watching it. So what we do is we're not going to then include those when we write the net ionic equation. But I'll give you a minute to write down those points first of all, just so you've got this stage in your books. Then if we look at the net ionic equation, we've left out the spectator ions. So what we have is H plus OH minus makes H2O. So that's the net ionic equation. We're not looking at the spectator ions here because they're unchanged between the reactants and the product side. All we're looking at are the ones that have undergone a change between those two sides. So jot down those couple of points for me. You may be sitting there wondering, well, where on earth am I ever going to need to do this? And the answer is we're going to be using these net ionic equations to model specific reactions called precipitation reactions. And a precipitation reaction is just one where we start off with two solutions, and when we mix them together, the reaction that's undergone there generates an insoluble solid, also known as a precipitate, hence precipitation reactions. So where we've got two solutions, mix them together and we form an insoluble solid, that's a precipitation reaction, and the net ionic equations are what we can use to model those. Your turn to have a go then. So for each of those three reactions, write the complete ionic equation, the net ionic equation, and then underline or highlight any of the spectator ions. So here's the answers then. I'm not going to read them all out because it will make me sound like some kind of a weird bingo caller, but I'll leave them up on the screen for you to have a look at. Obviously what we've done is the spectator ions are highlighted in red on the screen. Part A is going to be the complete ionic equation and B the net ionic equation. So you get 3 marks for each of the 3 questions. 1 mark if you've got the complete ionic equation, 1 mark for the net ionic equation, and 1 mark if you picked out the spectator ions for each. So it's a total of 9 marks you can give yourself once you've had a look at your answers. Final thing for today then are the plenary questions. So those of you with target grades up to grade 5, the 2 columns on the left. Those of you with target grades over grade 5, it's the 2 columns on the right. So I'll leave these up for about 3 minutes today, but as always, if you need longer, hit pause and take as long as you need to answer them.